There is a calculation for a type of a problem that operators should be familiar with doing, and it's also one that operators actually do at a water treatment plant fairly often, and that is doing the chemical feed pump setting. So I'm going to show an example of that, and we have a word problem here, and the question asks, what should be the milliliter per minute setting on a chemical feed pump that is injecting a 20 milligram per liter dose of 50% sodium hydroxide into a water treatment plant flow of 1.3 mgd, and it tells us that the specific gravity of the sodium hydroxide is 1.5. There's a lot of information in this word problem, and it always helps to draw a diagram and write the information on and then determine what formula we're going to use. So I'm going to draw a simple diagram of what this problem might look like. And this would be typically of how it's set up in a water treatment plant. So this is our storage container of 50% sodium hydroxide, which is often written NaOH. And this is what we call a calibration column. This is what we're going to determine our setting on our chemical feed pump. It's a small pump, has some knobs on it. The newer versions are digital, so push button. And it takes water, it takes the liquid chemical and feeds it through the line and dumps it in to some location, and I'm just going to draw a pipe here at the treatment plant. And what we do when we're doing chemical feed pump calibration is we fill this container up with solution, sometimes water, sometimes the 50% sodium hydroxide. We turn the valve off so that now the chemical feed pump is drawing directly from this calibrated cylinder, and that we're able to measure the amount of milliliters that this is coming out of this cylinder over a minute to match the calculation that we've just determined. So this is our chemical feed pump, and we're injecting it, and what the dose that we're injecting is a 20 milligram per liter dose of sodium hydroxide, and the flow through the plant is given as 1.3 mgd, and we're being asked to determine how many milliliters per minute do we have to make the adjustment on the chemical feed pump in order to add a dose of 20 milligrams per liter into a treatment plant flow of 1.3 mgd. The equation that we're going to use is on the first page of our ABC formula sheet, and it's this formula here, the chemical feed pump setting in milliliters per minute, and we'll write that all down. But that's where the equation is. It's on the first page, milliliters per minute. So let's just write that down. The chemical feed pump setting in milliliters per minute is equal to our flow in mgd times our dose in milligrams per liter times 3.785, that's a constant, times 1 million, and that's a constant, all divided by our chemical density in units of milligrams per milliliter times a constant of 1440. So that's the formula we're going to use to solve this problem. And let's see if there's any of the terms in this formula that we know without having to do any math. Well, our flow is this number here, 1.3, so that's nice and convenient. Sometimes that might be given in gallons per day or gallons per minute, and we'd have to convert that. Our dose is this value here, so that is convenient, 20 milligrams per liter. Those are constants. We don't have to change anything there. That's a constant. The only thing we need to figure out is this chemical density in milligrams per milliliter. And that is related to the specific gravity, which I didn't write down on here, but the word problem tells us that the specific gravity of sodium hydroxide is 1.5. which means this liquid weighs 1.5 times the weight of water. And we have to do that in terms of milligrams per milliliter. And you could look on your conversion sheet. The information is there. It's just not in a nice, easy format. But it does tell us that there are 1,000 kilograms. This is for water. 1,000 liters of water weighs 1,000 kilograms. And you can do multiple converting of units so that you can get that into milligrams per milliliter. But I think might be easiest, because it's just one conversion that you would have to commit to memory. But it's one that we use fairly often, in that water, the density of water is equal to 1,000 milligrams per 1 milliliter. That means that 1 milliliter of water, if you were to put it on a scale, would weigh 1,000 milligrams, or 1 gram. And like I said, that is a good one to commit to memory. And when we're given the specific gravity of any liquid, we can figure out what the weight of that liquid is in milligrams per milliliter by simply taking the sodium hydroxide. Sodium hydroxide weighs 1.5 times the weight of water. So if water weighs, the density of water, 1,000 milligrams per 1 milliliter times 1.5, that gives us 1,500 milligrams per milliliter, and that is the number that we can use there in our formula. So then we go back to doing our calculation and plugging the numbers in. Our chemical feed pump setting in milliliters per minute is equal to our 1.3 mgd times our dose of 20 milligrams per liter times our constant of 3.785 times our constant of 1 million gallons divided by our density, which we just found of our chemical is 1,500 milligrams per milliliter, times our constant of 1440. Everything on top, we multiplied this on our calculator, we will get 9841 with 4 zeros. Everything on the bottom, 1,500 multiplied by 1440, gives us 216 with 4 zeros. And when you do that out on the calculator, you get 45.5 milliliters per minute. So what that means is that we would fill this graduated cylinder up. It's usually 100 milliliters or 1,000 milliliters, and we would time how fast it drops in 1 minute so that we can make the adjustments here to get approximately 45 milliliters being injected every minute.